Hello everyone. In this video I'm going to make a review with you for lesson 3, mirrors and lenses. To start our video here, I want you to think about these two questions on page 105. Here you have the first question. Why do you think the word ambulance is printed backwards on the front of this emergency vehicle? If you look at the emergency vehicle, the ambulance is written backward. Why do you think so? You have to think about the properties of images that are formed by mirrors. Okay, so here to give you the answer, I want you to think about the rear view mirror of a car. So in the rear view mirror of a car, it would read from left to right, because mirrors reverse things. So here I'll give you the answer, but after I solve the question 2. If your hair is usually parted on the left side, how will it appear in your bathroom mirror? So left side, that means, as you know, mirrors, they what so here it will appear as right side. I'll show you the answer and write down the answer on your book. So these are the answers, just copy them. The rear view mirror of a car, it would written from left to right, because mirrors reverse things. The second one, right side. Let's move together to page 106. On page 106, it's talking about how do mirrors form images. As you know, because of reflection of light on a smooth surfaces. I want you to put in your mind again, we can see things because of reflection. Yani when objects reflect the light, we can see these objects. So here in this in this page, I want you to highlight this part here. From this part, just hold on. A very smooth surface such as mirror reflect light in a uniform way. As you know, you remember this one. Look at the illustration below. It shows here how it will be. I want to show you after I make this highlight here. This part very important. Okay, then if you finish highlighted, let's go down to the figure. On the figure here, it shows how the light is reflected on smooth surfaces. It will reflect in a uniform way. As you if you remember this one, it will be reflected how? In a uniform way, if you remember this one. Also, we have said the law of reflection, the angle of incidence equal to the angle of reflection. How to determine the angle of reflection and the angle of incidence? You have to draw a normal. This normal, the angle between the normal and the incoming ray, it shows what? The angle of incidence. Okay, so this one here, this is it equals 40. It's the angle between normal and incoming ray, and the normal between the normal and reflected ray, it's called what? The reflected the angle of reflection. Here the normal and the surface, it's how much? Is 90 degree. The normal, it helps you to determine and to draw the reflected ray and to make it clear. As you know, here some students for question 5, okay, they took this, they used the protractor to measure the whole angle. This one is wrong. The question is asking to measure this angle between the incoming ray and normal. It needs what? The angle of incoming ray, or the angle of incidence, and is asking to find the angle between the normal and reflected ray, which is the angle of reflection. If you measure it, you will find this one is equal how much? 60, and this one is equal also 60 because of law of reflection. Okay, here don't find this one. I don't need the outer one. This outer one is between the incoming ray and the surface, the reflected ray and the surface. I don't need it. This one is the this outer angles. Maybe in the exam I'll ask you to do this. You have this one, for example. I gave you this part only. I told you this part is equal how much? 30. Then I'll ask you to find the angle of incidence and the angle of reflection. You don't have any other information. All what you have this angle, and you don't have a protractor. What are you going to do? As you know, the angle between the normal and the surface is how much? Is 90 degree. So 90 minus 30 is equal how much? Is equal 60, sorry. So 99 minus 30 is equal 60. So the angle of incidence is 60. Go back to the law of reflection. The angle of incidence is equal to the angle of reflection. So at the end, this one here 60. Okay, so this one here also, it will be how much? It will be 60. Very important to study this figure. Okay, to know this and to know this. Very important. Now let's move to page 107. On page 107 here it's talking about what? A plane mirror. And you know, a plane mirror, we studied how to draw the image on a plane mirror by using two rays, light rays, and you have to apply the law of reflection. Okay, you have to go back to that video and study how to draw this image, and what are the properties of the image that is formed by what? A plane mirror. The first one is virtual image, is an image appears to be formed in a position somewhere behind the mirror, or as it is written in your book, a virtual image is an image that appears to come from a place that the light does not actually come from. It doesn't matter, the same meaning. Okay, also is formed when the light rays diverge after reflection. If you remember, when we when you draw the image of in the plane mirror, the light ray, when they reflect, they diverge, but you take the extension of these rays, right? Remember these five properties: is upright, the side is the same, left, right, reversal, and the distance from the image is the same as the object from the mirror. Okay, okay. So also to study on page 107 is enough to study the properties, these properties in this slide. I gave you, when we studied this lesson, I gave you two questions. Explain how the image of an entire school bus can fit into cars a small a small rear view mirror. Okay, so this one here, the answer: the farther an object is from a mirror, the smaller it appears. The second question: if you are standing 2 feet in front of a plane mirror, how far away from you, look at this one, from you, will your virtual image be located? Explain your answer. Here my virtual image, it will appear 2 feet, 4 feet away. Why 4 feet away? Because I am located 2 feet in front of the mirror, and my virtual image appears to be located 2 feet behind the mirror. Therefore, the distance between me and my virtual image is 4 feet. Okay, so this part is very important. Copy the answers on your notebook. Let's move now to the second part of mirrors, spherical mirrors. You know, we studied two spherical mirrors, concave and convex mirrors. Here on page 108, you have the definition of a concave mirror. So here, a mirror is curved inward like the ball of a spoon. Concave mirrors, they are known as what? They are converging mirrors. Why they are converging? Because here, if you pointed a parallel light ray toward the concave mirror below, they would converge at point called focal point. You remember the rays that we studied before? I want to remind you about these laws. The laws, when they pass, they reflected from what? A concave mirror. You have 3 rules. These very important to memorize them and to understand them and to practice how to draw them. So a ray of light which is parallel to the principal axis after reflection passes through the focus. Okay, so, or the focal point. And these 2 rules, very important. We have studied in this lesson the meaning, and it's converging. We said all images are formed where 2 or more rays, you can use 2 or more rays. 2 rays are enough to draw the image. If you remember, we said for concave mirrors, only 2 rays are enough to draw the image. Okay, don't forget to study this one. They have the ability, concave mirrors, to form what? A virtual image, a real image, and a real image, both virtual and they can make both. Here, make both virtual and real image. Okay, and you have to know real image is formed where light from an object converges when they come together. A real image can be projected into screen, a virtual image cannot. This one is important. We have studied also 2 cases. We mentioned wherever you put the object in front of concave mirror, that affect the image that will produced, right? We have studied 2 cases. These 2 cases, you have to practice and know what are the rays that we use to draw the image, and you have to know the property of the image for each one of these 2 cases. Okay, then here also, this one very important to study this, and the exam for sure, it's online exam. You will not not draw the images, but you have to predict what are the properties, where is the location of this object. Why? Maybe I'll ask you, these are the properties, where is the location, where is the position of this object in front of concave mirror. Okay, also you have to know these rays, how they will be reflected. The rules, very important. Let's go now to the other part. The other mirror, it's called what? Convex mirror. For convex mirror, you have to know this one, convex mirror, curves outward like back of a spoon. Convex mirror cause beam light to diverge, so it's diverging mirror. Okay, so that means spread apart the light as if it came from what? A focal point behind the mirror. You have to know the rules for the convex mirror also. Okay, we have studied 2 rules for convex mirror. For convex mirror, all images formed by convex mirror are virtual, right side up, and the small. Convex mirror are useful because they make small images of large area, so they are used in security, they are used in cars. This part very important. You have to know these properties and what are the rays that we have used and how to draw them and how they are appear. Okay, Wherever you put the object in front of convex mirror, it will give the same property. It's always what? Virtual image. Now I want to remind you about the rules for convex mirror. Two rules. Ray of light which is parallel to the principal axis, after reflection it appears to be coming from the focus. Okay, they are scattering, sorry, they are diverging. So now let's move to the other part. We finished from mirrors. The other part, it's talking about lenses. You have to know the meaning of lenses. This part very important. What does a lens mean? It's a clear optical tool that reflects light. Refraction occurs when light passes. As you know, you remember in the previous lesson we took the meaning of refraction. So this part also important because it's repeated, but it's important though. The change in speed makes light wave bend and either it converge or diverge, right? Depending on the lens for sure. The property of the image that is formed, it depends on two things, two factors. What are these two factors? The position of the object, where is the location of the object, how close from the lens or how away from the lens. The other one, the type of the lens that is used or the shape of the lens. Okay, let's start with the first lens, which is the convex lens. For convex lens here, form both real or virtual image. You have to know the meaning of convex lens. Convex, it's called also what? Converging lens. It's thicker at the center than the edges. Okay. Also this one here, why it's converging? Parallel rays of light converge at a focal point after they pass through convex lens. This one, very important. For the image that is formed, it depends where is the location or the position of the object in front of the lens. We took two cases, case 1 or case 2. And depends on where is the location, it will make what the properties of the image will be different. We have studied this. You have to go back to that video and see the slides that I bought. Also here is very important, this one very important, the uses of convex lens. I want to remind you also about the rules that are for the convex lens. Look at this one, it shows how convex lens is what is the converging. Also the rules, you have 3 rules. Only 2 rays are enough to draw the image, as we learned. For this one here, these rules very important to understand them and be able to draw them and to memorize them. Okay, don't forget here these images, how they are formed, what is the property of the image for each one. Yani, depending on the location or position, you have to know what is the property of the object of this image. Very important to know each case. Okay, and how to draw it, what are the rays that we used. The last one, it's talking about what? Concave lens. Concave lens, it has only one case. Yani wherever you put the object, it will make the same property for the image. For this one here, let's talk about the main thing for the convex. It's diverging. The first one is diverging. It's not converging like a convex lens. For concave is what is diverging. Is thinner at the center than the edges. Look at the shape of it, this lens, this one here, it shows. This one, light passes through a concave lens is refracted outward as from the focal point. Okay. So look at these rules for concave lens. these rules are very important. So a ray of light which is parallel to the principal axis after refraction appears to be what coming from the focus. So put in your mind, mirrors reflect light, lenses they refract light. Okay, here this one, let's go back to our the first one where we highlighted. Also because they are refracted away from each other, parallel light waves passing through a concave lens don't meet, so they diverge, okay, at the end. So this one also is important. Always is what is a virtual image. Here the property of the image is always the same. Wherever you put the object, it should be always the same. You have to know only two rays are enough to draw it. You have to know also the property of the image that is formed. Look, it is small, smaller, as you see. It's this one is virtual. Diverging lens are used to spread light. This part very important, often in combination with other lenses and telescope, binocular. They are also used in what, eyeglasses, to correct for nearest sightedness. Okay, this one very important, and you have to know the rays. The last thing that I want to talk about, look at this table here. From the property, you have to know which type of lens is this and where we can use it. I'll give you the answers to check your answers. So check the answers here. These are the answers. You can check them. Don't forget to go to page 112. You have the questions and the answers. Quiz yourself. Also, you have questions on page 13. These questions on page 13, you will find the answers on portal. But if you have any question, you can send me your question. Thank you for listening.